utopia in this future city. But at present, cities are one of the most destructive forces on the planet. They're key to the global warming which is affecting us right now. So how can nature help us curb these destructive ways?
We are currently coming to the end of an energy boom, a time when energy has almost been limitless. The 160 million buildings in the EU use over 40% of Europe's energy and create over 40% of its carbon dioxide emissions, and that proportion is increasing. By exploiting energy, we're changing and damaging the very thing that supports us. When either the oil runs out, or more likely, the effects of climate become more severe, we're going to have to change the way we do things. Once again, it's the heating and cooling of our buildings that is causing us problems. A tiny insect that builds its home in the most extreme environments might just have the answers. Dr. Rupert Saw of Loughborough University has a very keen interest in the humble termite.
So the reason we want to look at these structures is that buildings of the near future are going to have to be optimized very quickly for the environment they're in.
The particular species of termite that Rupert is studying builds its home in sub-Saharan Africa, where during the day the temperature can soar as high as 35 degrees Celsius and at night plummet down to 14. But incredibly, inside the termite mound, the temperature stays constant.
We associate energy in our buildings quite simply with electricity or even gas. But to termites, well, they're using wind, they're using sun. There's many, many different sources of energy that can drive a system.
So it's an exploitation of ambient energy that we can really start to learn from these masters.
Maybe we can get some of these self-regulatory or energy controlling capabilities into the very fabric of the buildings we build.
Can we apply the lessons of this tiny insect to our homes?
In this scenario, our little house will keep cool in much the same way as a normal house does. It will all be about air seeping in through the windows and through the gaps. We're also going to pop in a little thermocouple. That will tell us how hot it gets. And now, all we need is the sun. As you can see, our house has got very hot, and this is the problem with traditionally ventilated buildings. Now, normally what we would do is stick a big air conditioning unit on the side of it to keep it cool and use lots and lots of energy. But there is a way, if we look to nature, that we can keep exactly the same building cool without using any electricity whatsoever. Now, we've added this big chimney, so as the house gets hot, the air will get hot and rise up and out of the chimney. Now, what termites do is draw the air deep in underground to make it nice and cool, and that's what we're doing over here. We're taking air in through these tubes and down through some water that is cooler than the air temperature. It will then go into the house and keep it cool. So this is acting like a zero-energy air conditioning unit, exploiting the fact that during the day, the ground is always cooler than the air. Well, this has been running for a little while now, and we're actually seeing that it's at 25 degrees. So this setup is actually 6 degrees cooler than in a traditionally ventilated building. So this system really does work.
And it's being used in some buildings already. The Ionica building in Cambridge, like the termite mound, uses natural resources to regulate temperature.
We're in one of the wind towers. It all looks very simple. What's it actually doing?
What happens is the wind blows across the top of the tower. We've got a lid to stop the rain falling in, but as the wind hits the edge of the tower, it creates a turbulence, which in turn creates a negative pressure. And as that negative pressure works, so it drags air from the atria space. And here we have the atria space, and the air comes up through those grills, through the atria space, and up and through, and then it comes out of the wind tower and is ventilated. The air comes through a window that we can open, and it goes out of a chimney. And that's really it. It's very simple. Not dissimilar, actually, to termites. Same principle. Open the hole to the top of a termite mound, more air flows through it.
And does it save them money? Does it really save money to have this natural ventilation system?
Yeah, I think the building costs no more to construct, but also on top of that, the running costs are reduced probably about 45%, 40% of that order. So the client's made no additional investment, gets all the benefit of a low running cost. So of course it makes total financial sense.
The benefits are clear. Significantly lower bills and no extra cost to build.
It could be that in the future, buildings will be able to harvest all the energy they need from their immediate surroundings in a completely sustainable way. In order to do this, they will have to respond and evolve to fit their local environments in exactly the same way as species do. Imagine architecture matching the richness and variety of the natural world.